Good morning everyone, myself Pawan D. My lesson number is 21BBTCD069. Today we are gonna learn about pointers. So what is pointers? Pointers is an unique variable that stores memory address of another variable. As we can see here, when declaring a variable, the compiler sets aside memory storage with a unique address to store that variable. The compiler associates that address with variable's name. When the program uses the variable name, it automatically accesses a proper memory location. No need to concern with which address. But we can manipulate memory addresses by using pointers. Let's say now here we can see that we can change the memory address of an variable with, using pointers. As an example, we can see here a variable named end rate of integer int end rate equals to 10. Here we have got a program about how we can change the memory location of the another variable. So you can see we got void function and the int n rate equals 10. Then we are gonna print a variable name and its size and its initial value stored as n rate and the memory address of an n rate type. Here you can see the output as we got memory address of an n rate is 008. The variable is stored at the specific memory address and can be decrypted as follows. You can see it is stored at 00A as we have seen in the program. 10 is a current stored value. As we wrote int n rate is equal to 10 and variable name is n rate and the memory address is 000A. The variable scope is local to the main function. The memory allocation is from the main function's stack. The n rate memory address or any another variable is number, so can be treated like any another number in C. Using %p, the address is hexadecimal format. While using the %p, we can find out that the address is in hexadecimal form. Hence, if a variable memory address is known, we can create a second variable for storing the memory address. From previous example, let's declare another variable named python rate to hold the address of the nrate variable. At the beginning, python rate is uninitialized. You can see here. Python rate is uninitialized. So storage has been allocated, but its initial value is undetermined, as shown below. See, it has been stored, but its initial value is undetermined. Means its value is not determined here. Let's store the n rate. Let's store the n rate memory address in python rate variable. So python rate now holds the n rate's memory address where the finally actual data 10 is stored. Finally, in vocabulary, python rate is pointing to n rate or is said to be pointer to n rate and can be illustrated as follows. Here we have named the memory address as its value of python rate. So the pointer variable declaration becomes something like this: int pointer python rate. In other words, python rate variable holds the memory address of n rate and is therefore a pointer to n rate. The asterisk is used to show that is the pointer variable instead of normal variable. You can see if you're gonna use the pointer function pointer variable in it, so you have to mark as a asterisk symbol. By using pointers, it is an efficient way of accessing and manipulating data, very useful for dynamic memory management. As we know, memory registers and cache are scarce resources in computer. Every computer system there are fixed and limited amount of memory for temporary data storage processing. There are loading and unloading data into and from moving data from two different locations of the memory, including the cache and the processor registers for temporary data storage and processing. In every computer now, it has a fixed limited amount of memory. Like it has like example 6 GB RAM, 8 GB RAM, and 64. It has limited memory storage. So the loading unloading need an efficient memory management. Some of the memory portion also used for shared data to further optimize the utilization. The shared data access read or write depends heavily on the pointers manipulation. Pointers, yeah, you can see here, like computer has limited data storage, and to find that your memory address of any variable, you need pointers to use it, and through it you can manipulate its address and its variable value. Pointers and simple variables. A pointer is a numeric variable and, like other variables, must be declared and initialized before it can be used. The following is general form of declaring a pointer variable. You can see an example like char and asterisk symbol is a ch name, and int n type of char, float asterisk f value. Type of store data is any valid pointer based type such as char, int, float, or other valid C derived types such as array and struct. It indicates the type of variables data to which the pointer is pointed. The pointer variable name follows the same rule as other C variables. Naming convention and must be unique. From the pointer declaration examples in the first line, declaration tells us that ch name is a pointer variable of type char. The asterisk is also called indirection operator, and it indicates that ch name is a pointer to type char and not a normal variable of type char. Note the position of the asterisk. It is valid for all the positions pointers can be declared along with non-pointer variables as shown below. You can see here pointers can be declared with non-pointers. An example. Once a pointer is declared, we must initialize it. This makes the pointer pointing to something. Don't make it point to nothing. It is dangerous. Uninitialized pointers will not cause a compiler error, but using an uninitialized pointer could result in unpredictable and potential disastrous outcomes. We can find the point where we should not use uninitialized pointer. It can give it can give some problems for the outcomes. So we should not use an initialized pointer until pointer holds an address of a variable. Isn't useful. C uses two pointer operators. Indirection operator asterisk symbol has been explained. Address operator ampersand symbols means return of the address. You can see the programming C. It uses two types of operators. Asterisk symbol it is used for pointers, and address of operator is ampersand. When ampersand operator is placed before the name of variable, it will return the memory address of the variable instead of stored value. Example of an initializing pointer, you can see the data asterisk p2 int equals 100. The address is been given for it 0012ff54 in the location. In this example, pointer variable p2 int receives the address of n location or the memory address of the n location variable assigned to p2 int pointer variable. Graphically, you can see here that the second variable has got its value as 0012ff54, and the n location as we placed it, it got an stored value as 100, and its memory address is 00125. The asterisk operator is a complement of ampersand operator. Asterisk means returns the current value of variable pointed to. From the previous example, if we declare another variable of type int another variable, as example you can see here int asterisk p2int equals to and n location equals to 100. In the statement another variable equals to asterisk p2int, we'll place the actual current data value stored in variable n location into variable another variable, which means another variable was assigned the actual current data value stored at the memory address held by p2int. The asterisk operator appears before a pointer variable in only two places: when we are declaring a pointer variable, when dereferencing a pointing variable to show that data is pointed to. How to use pointers now we are going to see it. Only the addition and subtraction operations are permitted in pointers expression. As with many variables, a pointer may be used on the right hand side as an assignment statement to assign its value to another pointer as shown in the following example. Here in example we can see pointers variable. It is used in asterisk a pointer to 1, asterisk a pointer to equals 100. Normal variable inum equals 100, and here you are gonna get the same value, that is 100, at the memory locations. The situation can be illustrated as shown below. The memory address should be different for different run or system. Take note the difference between memory address and the actual data value which stored at the memory address. Do not worry about the address which are determined and provided by the system. From the previous example, we can see that the access the variables content by using variable name inum and is called direct access. Access the variables content by using a pointer to the variable asterisk I pointer 1 or asterisk I pointer 2 and is called indirect access or indirection. As a conclusion, if a pointer named p pointer variable of type int has been initialized to point a variable named inum variable, the following are true. Declare a pointer variable named p pointer variable where the data stored pointed to by pointer variable is int type. Int asterisk p pointer variable, assign the, here you can see p pointer variable equals ampersand of in num variable. As a result, p pointer variable and inum variable both refer to contents of inum variable, that is whatever data value stored there. P pointer variable and inum variable not the actual data, are not the actual data. So pointer name without the indirection operator access the pointer value itself, which is of course the address of the variable pointed to. As an example, you can see a program. The address displayed of variables I no, normal variable may be different on your system because different computer will have different specifications. For pointer arithmetic operation, only two arithmetic operations, that is addition and subtraction, available. For example, int I age equals to 35, hence C is reserved storage for the variable I age and store the value 35 in it. Let's say C has stored this value at the memory address 1000. Then we declare a pointer variable named p pointer to age, that to point I age variable. Then after the following expression have been executed, int p pointer to age equals and I age p pointer to age. The content of the pointers becomes 1004 instead of 1001. The integer value takes by 4 bit to C and add 4 to the pointer. Different variables types occupy different amount of memory. Implementation dependent following C standard or implementation. Extension and whatever 16, 32 or 64 bit system. Each time the pointer is incremented, it points to the next integer, and similarly when a pointer is decremented, it points to the previous integer. Each individual byte of memory has its own address, so multi-byte variable and actually occupies several addresses. And the pointer used to handle the addresses of multi-byte variable. The address of a variable is actually the address of the lowest byte it occupies. For example, you can see int inum equals to 1252 equals 4 byte, and character variable equals to 90 equals 1 byte, and float variable has 4 bytes. The pointer variables are pointing to the lowest byte of variable memory slots. As example, I num occupies 4 bytes and ch variable occupies 1 byte. Other pointer arithmetic operation is called differencing, which refers to subtracting two pointers. For example, two pointers that point to different elements of the same array can be subtracted to find out how far apart they are. Pointer arithmetic automatically scales the answer so that it refers to the array elements. Thus, if p pointer 1 and p pointer 2 point to the elements of an array of any type, the following expression tells you how far apart the elements are. P pointer 1 minus p pointer 2. However, PTR difference by t. Type can be used to return the subtraction operation between two pointers. It is a base signed integer type of C or C++ language. The type size is chosen so that it could store the maximum size of theoretically possible array of any byte. On a 32-bit system, pointer difference will take 32-bit. On a 64-bit system, 164-bit. The type enable you to write well portable code. So pointer different together with char t size defined as stddef.h for C++. The pointer comparison is valid only between pointers that point to the same array. The following relational operators work for the pointer operation. False. A lower array element, that is those having a smaller subscript, always have a lower address than the higher array elements. Thus, if p pointer 1 and p pointer 2 pointing to the elements of the same array, the following comparison is true. If pointer 1 points to an earlier member of array than p pointer 2 does, many arithmetic operations that can be performed with regular variables, such as multiplication and division, do not work with pointers and will generate errors in C. The following table summarizes the pointer operations. As you can see, assignment operator, you can assign a value to a pointer. The value should be an address with the address of operator ampersand, or from a pointer constant array name. Indirection, the indirection operator gives the value stored in the pointer to location. Address of ampersand, you can use the address of operator to find the address of pointer, so you can use pointers to pointers. Incrementation, you can add an integer to a pointer to point to a different memory location. Differencing, you can subtract an integer from a pointer to point a different memory location. Comparison, weld only with two pointers that point to the same array. Let's say we have declared a pointer something like this: int asterisk pointer variable. This statement declares a pointer to type int but not yet initialized, so it does not point to anything known value address. Then consider the following pointer assignment. As you can see here, if we are not gonna initialize it, then it is not going to show the data type value or any address of an variable. These statements mean value of 1 to 1 is assigned to whatever address. Here you can see it. In pointer variable is pointing to the that address can be anywhere in memory location. Yeah, as I said, you can't. It is not fixed in that memory location. It can be anywhere, which may contain critical data. The 121 stored in that location may overwrite some important information, and the result can be anything from program error to a full system crash. We must initialize a pointer so that it point to something. Do not create a stray pointer. A better solution, we can assign null value during the initialization before using it, such as yeah. If we initialize pointer without an variable, it is gonna make issues for you. You can see if you don't have anything to initialize, you can use it as use null to prevent any harm to your system. For pointer, the point to a string, you may just point to an empty string for a dummy, such as char asterisk my string equals null. The .NET C or C++ program using null pointer instead of null. The null or null pointer is a pointer that point to the 32-bit system's memory address. You can see here as it done null pointer and empty string. Arrays and pointers. A special relationship exists between pointers and arrays. An array name without brackets is a pointer to array's first element. So if a program declared an array, you can see char ch name 10. Ch name, array's name is address of the first array element and is equivalent to the expression, which is a reference to the address of the array first element. Ch char name equivalent to ch name equals 0. The array name is therefore a pointer to the array first element and therefore to the string. A pointer is a constant which cannot be changed and remains fixed for the duration of program execution. Many strings operations in C are typically performed by using pointers because strings tend to be accessed in a strictly sequential manner. You can see the program as an example. Enter a line text of equals a simple line of text. can be listed as follows. You can see here as they did it, the memory address, the variable. And take a look on the example of the pointers and array. As we can notice the difference between the elements addresses 12ff40 12ff3c equals 4 bytes for int, and as it takes 4 bytes for float, but here we can see it is taking 8 bytes for double. As example, we can see another program here. As for today's session, it is over here.